Hey everybody, this is Dan from Abbott University, and in this video I'd like to go over how to solve a particular kind of problem that you may have to face when you're dealing with learning how to multiply and divide fractions. And that kind of problem is namely where you have fractions within fractions. So as you can see here, we have a fraction in the numerator and a fraction in the denominator. Another kind of problem that you may have to face is where you have a whole number in the numerator and a fraction in the denominator. And then finally, there's another problem where you have, as you can see here, a fraction in the numerator and a whole number in the denominator. And what I'm going to do is I'm going to go over each of these one by one. Now, it so happens that there is, as usual, a textbook way of solving these kinds of problems. And what we're going to do is we're going to veer from the textbook approach, and I'm going to present to you kind of like an imaginative and visual shortcut that is a little weird, but it has worked for me throughout the years. And I believe that if you're someone who has an active imagination and are more specifically a visual thinker, you might take to this particular approach, and it will at least make it so that you will probably never forget how to do this. And basically, we could start with this situation here, where we have a fraction in the numerator and a fraction in the denominator. Now, here's what I do with these kinds of problems. Again, there's a textbook way of going about it that you'll probably learn in school, but whenever I see something like this, the way my mind goes is I take a look at this fraction in the denominator, and literally I imagine this giant hand like grabbing the fraction in the denominator, and I picture that hand grabbing it out and then flipping it upside down, and then in a sense smashing it into the numerator. So again, it's kind of strange, but it does tend to work where, again, you imagine just pulling this fraction out and then turning it upside down and flipping it and smashing it into the numerator. Now, what do I mean by smashing? What I mean by smashing is you're just flipping it upside down and you're multiplying it to the numerator. So 3/4 flipped over is, of course, 4/3, and we will be multiplying those two together. And after I do that, I then completely forget about the bottom entirely, and I focus only on this situation up here. Now, as many of you have probably learned, multiplying fractions is pretty easy in that all you're really doing is you're noticing the numerators and you're multiplying straight across. Noticing the denominators and you're multiplying straight across. Now, before we do that, it's helpful to remember that sometimes you might have these opportunities to do what's sometimes called a cross cancellation. And what I mean by that is, before you multiply fractions across, always take a look at the diagonal relationships between the numerator of one and the denominator of the other, and vice versa. And what I could see here is there's this relationship between the 4 and the 2, this diagonal association, and you always want to ask yourself, are there any common factors between these two diagonal numbers? And if there are, then you could search other than 1, that is. So every two pair of numbers has a common factor of 1, but we're looking for common factors that are other than 1. And if there are, you're going to want to find the greatest common factor. Now, some of you probably know already the number 2 happens to be the greatest common factor of both 2 and 4, because 2 divides into 2 evenly and 2 divides into 4 evenly. So what we're going to do is we're going to go ahead and actually do that, where 2 divided by 2 is just 1, and 4 divided by 2 is 2. Now, instead of multiplying this 1 times the 4, I'm going to be multiplying this 1 times the 2, and instead of multiplying a 2 times the 3, I'm going to be multiplying this 1 times the 3. So, that 1 times the 2 would give me a 2 in the numerator, and this 1 times the 3 would give me a 3 in the numerator. And that right there, that 2/3, is the answer. And it's always a good habit to ask yourself, could even this fraction be reduced? Because your teacher is going to want you to reduce your answer especially. And you know a fraction could be reduced if the numerator and the denominator both have a common factor other than 1. And then if so, then you'd want to divide both the numerator and the denominator by the greatest common factor. And then you would end up with kind of like a smaller representation of that value, or at least an equal representation of that value that features smaller numbers, if that makes any sense. So that's how you can think about working with the kind of problem where you have a fraction over another fraction. So I'm going to clear the space here, and we're going to look at another situation. This next situation's very similar, and actually we're going to do pretty much the same thing, where basically any time I see a fraction in the denominator, I once again imagine that hand grabbing this fraction that's in the denominator and then pulling it out, flipping it upside down, and then smashing it, i.e. multiplying it times the numerator. So what we end up with here is 2 over 1 times that 3. Now that 3 times 2 over 1, what we're dealing with here is obviously a whole number times a fraction. Now to give ourselves a little bit of space and breathing room, I'm going to rewrite that situation, this situation right here, right up here. So what we're dealing with is a 3 times a 2 over 1. Now, to be honest, there's actually a few different places or ways that we can go about this. One way of going about it is we could know, of course, that 3 is a whole number, and that 2 over 1, well, 2 over 1 is really just 2, because any number over 1 is just itself. So you could then just treat this as 3 times 2, and that would equal 6. Now, another way to go that you might learn in school is whenever you're multiplying a fraction times a whole number, it could be very helpful to just remember that every whole number has that 1 underneath. It's almost like the opposite reasoning of what we did here. So we have 1 as an invisible secret denominator underneath this whole number of 3. And then you would just go ahead and multiply straight across, like you do when you multiply any fractions together. Multiplying fractions is really easy in the sense that it's intuitive almost. You just multiply straight across, and then you end up with 3 times 2, well, that would be a 6 in the numerator. And then you end up with this 1 times 1, which is just a 1. Now, we already calculated that our answer is 6, and that means that we're on the right track here, because as you can see, this denominator itself is a 1, and therefore we're dealing with 6 over 1, which is really equal to just 6. Now, in my opinion, your teacher is probably going to like it if you represent the final answer as just a 6 instead of leaving it as a 6 over 1. Any chance you can get to show your teacher, or to, in a sense, even show off your knowledge to the teacher in a way that's conducive to simplifying the values, I would jump on that chance. It's nice to demonstrate that you know that anytime a 1 is in the denominator, it really means that we're dealing with a whole number in that moment. Okay, so that's that particular situation. And then we're going to move on to a third example. And now, so far, the examples that we've done feature a fraction being in the denominator. And once again, as a quick verbal review, anytime you have a fraction in the denominator, you could always imagine that giant hand grabbing that fraction that's in the denominator and then flipping it over and multiplying it times the numerator. Now, this particular problem is obviously different. We don't have a fraction in the denominator. Instead, we have a whole number in the denominator, and we have a fraction up top. So here's how to do this really quick if you want to use your imagination. Somewhere along the line, I realized that when I look at a problem like this, you see that we have this fraction up top and just a small little number down here. So it's almost like it kind of goes up in this bell shape like that, and then there's nothing really going on much over here. So it's this bell shape is being formed. Now, for some reason, my mind imagined that bell shape, and then it looked at this figure, and it's like, this looks like a UFO to me. It literally looks like a flying saucer flying around, maybe. And that's what it looks like. And not only that, but UFOs do this weird thing. You may have heard, I don't want to scare anybody, but according to some stories and legends, UFOs have a tendency to beam things up into the UFO. Sometimes there's stories of people walking around, usually at nighttime, like in a forest, and a UFO will beam up that person. It'll kind of emit these rays of light that cause whatever it is down here to go up into the UFO. So anytime I see a problem where we have the fraction in the numerator and a whole number in the denominator, I immediately see that bell shape and I'm like, that's a UFO. So now what does it mean when I say it's being beamed up? Well, basically, we're going to take whatever that number is, and I like to think of it being like beamed up into it, and then it kind of like absorbs and merges with this number here. So it gets like pushed up or pulled up into the UFO, and it merges or melts into this bottom number here. Now, what do I mean by melt? What I mean by melt or merge is that these two numbers get multiplied together. So I'd like to represent that situation right now. It would look specifically like this. Notice how the 1 just remains a 1, and then, but the real action is happening with that 3 and 2. We end up with a 3 times a 2, and that ends up being 1 over 6. Now if we look at this, this is a value that represents our answer. Upon inspection, we see that this is fully reduced. There are no greatest common factors other than 1. And that means that that happens to be the answer. So that's what you can do when you have a fraction in the numerator and a whole number in the denominator. So I know it's kind of weird, but probably because it's weird, it will make it so that it's harder to forget. Alright, so hopefully that's helpful, and I will see you next time. Thanks.